Here's a fun question for Riley. What's denser, an egg or water? If all that matters is relative density, then the egg should sink.
Funny you should ask that question. Today's video we'll be doing a little bit of science, and we will be observing how we can manipulate the medium by changing the density and create a force. Newton said where there is an acceleration, a force must be present. Today's video is all about science.
But first, some context from a science denier with a counter to my claims from a recent video of mine. The self-proclaimed physics degree undergraduate makes a claim and gets it totally wrong. Let's consider his words carefully. This guy claims to be a man of science but doesn't know what the cause is in an experiment. Neither does Geo Whisperer.
Between the density of the egg equal to the density of the medium it's in. But what Nora says is he equates cause with that which one manipulates. Well, your independent variable is the variable that is manipulated by the researcher in an experiment. It is the presumed cause.
Stop. The reason he's talking about this again is because he hasn't mentioned it here, but I think in this experiment, this video, they actually poured the salt in. So I think he's claiming you can change the density of the medium, and therefore that is the cause, or his independent variable is how much salt you've poured in. He hasn't mentioned this, of course, but I think that's actually what he's trying to get at. I mean, I know it seems insane what he's saying here about you have the control over the density, and but he actually means that that's because he's been pouring salt into it or not.
Yeah, exactly. You obviously do have the control over the density, but where's the connection from that to density is a force?
Yeah, I mean, there's exactly
no causal relation there.
Exactly, he's just gone off wildly into this quantum eraser dogma land where they prefer to live about dependent variables, and so he's just trying to prove forces because there's an effect as a result of changing the independent variable, i.e. the thing that is the cause in his mind. Although, of course, he doesn't like the idea of any cause has more than one factor, because, of course, you've got the density of the liquid, you've got the force of gravity. In other words, there are multiple factors, and he can't cope with that. Like, Nathan doesn't understand that an effect is the result of more than one factor. And
yeah,
so
apparently he doesn't understand that an equation can contain more than two factors.
Yeah. Yes, more than one factor. No,
more than one factor, actually.
Yeah, exactly right.
So we've got his words. We'll come back to them in a minute. It's clear that we need a definition or two for the rumpus. Let's not cherry pick one. Let's go with, say, 10. And let's see if there's a common theme for what is an independent variable. We're looking for what it is and the effect that it has on an experiment. Let's see whether his words were correct.
From Colorado Science and Engineering Fair, the independent variable is the variable which an experimenter deliberately manipulates in an experiment.
From Penn State University, there should be three types of variables in every experiment: the dependent, independent, and the controlled. The independent variable is what is varied during the experiment. It is what the investigator thinks will affect the dependent variable.
From explorable.com, the independent variable. This is what you change in order to provide a result. The dependent variable. This is what you are measuring.
From award-winning awardco.com, an independent variable is the variable that is changed or controlled in a scientific experiment to test the effects on the dependent variable.
From the University of North Carolina. In an experiment, the independent variable is the variable that is varied or manipulated by the researcher, and the dependent variable is the response that is measured. An independent variable is the presumed cause, and the dependent variable is the presumed effect. In experiments, the independent variable is the variable that is controlled and manipulated by the experimenter, whereas the dependent variable is not manipulated. Instead, the dependent variable is observed or measured for variation as a presumed result of the variation in the independent variable.
According to the GCSE citation in experiments, variables are used to help determine the cause and the effect. An independent variable can be thought of as the cause of change. a dependent variable is what is affected by the independent variable. There can only be one independent variable and one dependent variable in an experiment. Everything else that can impact the experiment must be kept constant or controlled. These are known as controls. The independent variable is controlled by you. In other words, you can manipulate the independent variable during an experiment to discover what effect it has on the other variables. This is the cause.
From practicalphysics.org, that's the Institute of Physics. The independent variable is the variable that is deliberately changed by the experimenter. The dependent variable, an outcome variable that is measured each time the independent variable is changed.
From the University of Southern California, the dependent variable is the presumed effect. The independent variable is systematically manipulated by the investigator. It is the presumed cause.
From Indiana University, independent variables are felt to cause some change in the dependent variables. They are manipulated by the researcher. Dependent variables are felt to be affected by independent variables. They are measured by the experimenter and are normally responses of the subjects.
By sciencing.com, the independent variable is the variable that the scientist changes during the experiment. Think of the experiment as a cause and effect exercise. The independent variable is the cause factor.
FE is getting the message. The independent variable must be manipulated. It is the presumed cause. There can only be one independent variable. This is science. It's really worth being aware of what it doesn't say is science. It does not say that you can infer additional causes. You cannot substitute in or introduce or suggest alternative causes. That would fall outside scientific method because there's no citations that allow you to do it. We need a quick position with regards to what is inferred cause. From the University of British Columbia, Richard Johns writes, "Before we can discuss inference to the best explanation, we must be clear on what an explanation is. That involves the notion of causation and also of inference. There is an important difference between physical causation and rational inference." Tim Osman calls this logic and reason. Causation is a physical process that happens in the real world, whereas inference is a mental process that occurs in the mind of a rumpus or a geostriber. There is a big difference between saying the physical event, the egg physically moves, or changing the density of the medium produced the egg moving, and knowing that an event or a gravitational force exists, that I can infer that that caused the movement. There is a big difference between the two. Surprisingly, perhaps one of the most common confusions in thinking about causation, or even among philosophers, in this case Rumpus, is to get mixed up with the inference. Do not make this mistake. Talking about you, Rumpus. One finds in this subject a kind of demonstration which does not carry with it such a high degree of certainty as that employed in geometry, and which differs distinctly from the method employed by geometers in that they prove their propositions by well-established and incontrovertible principles, whilst here principles are tested by the inference which are derivable from them. The nature of the subject, light, permits no other treatment. Well, thankfully in scientific method we do have other treatment. It's called scientific method. So it's only where you do not have any other treatment can you infer cause. But thankfully we do. We have scientific method.
This is an egg. This is a parts per million counter. Inspired by Jaron's most recent video. If you haven't checked it out, go to his channel, and it's called something like How and Why I Drink Distilled Water. He used one of these and he measured the amount of particulates per million in his tap water.
I decided that I could apply what he used, this little bit of technology, not science, this is technology. I could apply this technology and I could perform a practical scientific experiment where I could measure the density of a medium, in this case water, and I can make this egg move all by itself with just a little bit of salt. I can observe my phenomena to be that some objects appear to float, some objects appear to sink, some objects will suspend in different mediums. My hypothesis is if I change the medium's density, the egg will move. Newton said if an object moves, a force is present. My null hypothesis is that if I change the density of the medium, the egg will not move. I will activate one of the hypotheses. My independent variable, my presumed cause that I must manipulate in an experiment, is the density of the medium. My dependent variable is the movement of the egg. I will also try and keep everything else constant. The volumes of water, not null change, just the density of the medium. Let's see how I'm going to do this. This is my egg. This is my parts per million counter. This is going to measure the parts per million of both these fluids. This is tap water, regular tap water. That is the same tap water, but it's been preloaded to save some time with some salt from this to give it a density variation. It's going to measure the density of the tap water. So while it settles down, it takes a little bit of time. Okay, that's coming in at 212 parts per million tap water. Don't know what that means. It's just a number. It could be unicorn farts. It's just a number. So 212 is the recorded density of this one. Mind you, I should have showed that to the camera, shouldn't I? It's coming in at 214 now. So if you want to zoom in on that, it says 214 parts per million. Okay. Back to 0. When I do it to this one is saying this is 302 parts per million. Again, if you want to zoom into that, you can have a look. Okay, so basically 200 to 300. Let's try this one again. $208. Yeah, it's about 200. Then this one's about 300. Yeah, so it's 200 and 300, right? So one's got 100 more parts per million than the other. That tells me that there is a density variation between the two. So what we're going to do is we're going to see what happens when this egg is dropped into here. It sinks and it's touching the floor. Let's take the egg out. Now we'll see what happens when we put it into a more dense medium. So whilst that's settling down, this was done last night because it takes ages for it to dissolve and it get to a point where it's saturated. And I've got some residue at the bottom that is salt. So at the bottom at least it's getting relatively saturated. So I'm going to give it a stir to stir it up so that it evenly distributes a little bit better. Because what I'm hoping to do is get the egg so that it's just sat above the bottom of the thing. Some people will argue and complain and say that I shouldn't have stirred it, I should have left it as a gradient. It doesn't really matter. Because what we're trying to establish is, if the medium is different, does it make a displacement? Does it force a displacement? If it forces a displacement, according to Newton, there is force. This is just normal table salt from your favourite supermarket. Other supermarkets are available. We can tell that the density of the egg is equal to the part in the glass where the liquid is. What I'm now going to try and prove is that if I change the density of the medium, I will cause the effect by adding salt. So if I can change it, because I'm the experimenter and I'm manipulating my presumed cause My independent variable is the medium. That egg moves, I've caused it. We know the parts per million is about 300. All we need to do is pour some of this in. Hey, what do you know? The eggs immediately moved. Didn't have to wait for that, did we? So, what's the explanation? Well, I'm going to measure this now. This isn't going to be much more above 300. However, if it reads anything above 300, then that'll do for me. How do I reset? There we go. So the density is reading around about 309, 308, 309. If you can have a look at that on the camera if you want to zoom in. But I've just made the egg move. So what's the cause? Well, scientific method states that the independent variable is the presumed cause, and I presumed that change in the density of the liquid with salt would cause a displacement. Newton's first law of motion states that every object will remain at rest unless acted upon by a force, and I've obviously created a force. The density of the medium has displaced the egg. The egg moved. That's an accelerated mass. So therefore, Newton states that there is a force. I caused it with this. So in scientific method, the cause of the displacement is this. I've caused it. I've manipulated it. I added the salt. It caused something. I did it. I'm within scientific method. If you assert that gravity in any way caused something in this experiment, that means you are adding a secondary cause. Adding by inference. If you add a secondary cause by inference, you fall outside of scientific method because you can't infer an extra cause when you've already got one that you've manipulated. You can't infer a secondary cause and remain within scientific method. If you wish to move outside of scientific method, sure, be my guest. Infer that gravity caused in any way whatsoever the effect that we just witnessed, which was the egg moving. But you do so outside of scientific method. And we know by definition, if you are not complying with scientific method, you are practicing pseudoscience. I am staying within scientific method, and I am using my cause and my effect relationship, and I am demonstrating it with using this. I've changed the density of the medium, and the egg has displaced. Within scientific method, the cause is that and only that. You cannot infer extra causes. That takes you outside of scientific method. So, in anticipation of any reaction to this experiment in the video underneath or the comments underneath, if you assert that there is gravity acting on this in any way whatsoever, you are outside of scientific method and engaged in practicing pseudoscience. Unless you can show me a citation within scientific method that allows you to disregard the cause, the salt, the medium change, and then substitute an alternative one instead, or including adding to, then you are outside of scientific method. You are practicing pseudoscience. Just by way of footnote, it's interesting to think that the mass of the Earth is below this table. The huge Earth ball that we're supposed to live on. And that is pulling that egg down, isn't it? Apparently. Yet when I added an extra bit of mass to this, the mass below the egg has increased. But for some reason the egg went up. If mass really attracts mass, why didn't the egg go down? It's a rhetorical question. I don't want any answer. Just merely an observation. But if you're going to infer that gravity in any way whatsoever did something in this test, unfortunately you are working outside of scientific method. You're practicing pseudoscience. And nobody on the ball side would want to engage in pseudoscience, would you? The cause of the movement of the egg was changing the medium's density. I caused it by doing that. The effect was it increased a little bit of pressure at the bottom.
which displaced the egg. It moved. Newton said there was a force. So I've caused it. I did it with the sun. Gravity didn't do it. It wasn't the independent variable, was it? Can you science, bro?
Exactly, he's just gone off wildly into this quantum eraser dogma land where they prefer to live about dependent variables, and so he's just trying to prove forces because there's an effect as a result of changing the independent variable, i.e. the thing that is the cause in his mind, although of course he doesn't like the idea of any cause has more than one factor, because of course you've got the density of the liquid, you've got the force of gravity. In other words, there are multiple factors and he can't cope with that. Like, Nathan doesn't understand that an effect is the result of more than one factor. And
yeah,
so
apparently he doesn't understand that an equation can contain more than two factors.
Yeah. Yes, more than one factor. No,
more than one factor actually.
Yeah, exactly right.
An independent variable is the presumed cause.
There can only be one independent variable and one dependent variable in an experiment.
The independent variable is systematically manipulated by the investigator. It is the presumed cause.
Think of the experiment as a cause and effect exercise. The independent variable is the cause factor.
Here's a fun question for Riley. What's denser, an egg or water? If all that matters is relative density, then the egg should sink.